Everyone, and that was Thelonious Monk, and Epistrophe is the title of the work. Thelonious Monk goes back a long time ago, and he was a very big influence on John Coltrane, who in jazz you've probably heard. We played some John Coltrane in here. Now, during the weekend, one of the fellows who's in the 8 o'clock hour coaches a soccer team. Okay? And over the weekend, I've had a couple opportunities now to watch the team play. They're in first place, undefeated, playing beautiful soccer. And they were behind in the first half. And I listened to Leo talk with the kids in the middle of the field, and here was his statement. And what I'm going to have Marcella do is put this on the screen. This is pretty much what he said. They were behind. He says, "You have scored 3 goals in 10 minutes." Let's come off that for just a moment. Now, I have watched a game 2 weeks earlier. They were behind 2-0. And in 10 minutes, they scored 3 goals, won the game. It was really a great game in terms of just enjoying it. So this is what he said. There, around the middle of the field, coming back to the statement, you scored 3 goals in 10 minutes 2 weeks ago. Now you've got 30 minutes left to play. How many goals could you score in 30 minutes? That was a how much problem. Can you do that one in your head? Look at the screen. Give me an answer in your head. In your head first. Just in your head. I don't want you to say it out loud yet. How many goals could they score in 30 minutes if they can score 3 goals in 10 minutes? Get an answer in your head. This is called proportional thinking. Now we can set it up using dimensional analysis. Okay, now we can come off there. What was your answer? 9 goals, right? 10 minutes, 3. 30 minutes, 3 times as long, 3 times as many goals. Set it up for me as a dimensional analysis problem on paper. Set it up as dimensional analysis for me on paper. You know how to get the answer without this method. Now get the answer with the method. Dimensional analysis. Okay, Marcella, can you go back to that shot again one more time? I know I didn't think I'd be going there again, but I am. So I want you to go back there for a moment. This is somewhat unusual for me. And then as I go over there, what I'm going to ask you to do is give me a little bit of space. Just zoom out just a little bit. Leave the bottom about where it is. So come up. That's a little bit too much. I'd like this to be at the bottom of your shot, and then shrink it up so we have, there we go, nicely done. Now I want this as a dimensional analysis problem, so I'll give you a few more moments. If you can do 3-dimensional analysis problems in 10 minutes, how many dimensional analysis problems can you do in 30 minutes? It's like a test question. Okay, but how are your setups going to look? If you can do this problem, things are good. If you cannot set this one up properly, things are not so good. This is your very short Reader's Digest version of how well you're doing. So we'll let you set it up. You should be able to set this up in dimensional analysis. And we can do it with 2 fractions multiplied together. So I'll have 2 fractions multiplied together. So the first one, as I come into the camera, I'm going to put up here. And then a second one. And when I get done, I will have the 9 at the end. What do I want in the answer? Goals. So I'm going to put here goals. So what must go in the first fraction? The goals. So whatever else, goals have to go here. Now, do I have information that allows me to do that? 3 goals, 10 minutes. Now, that is called a unit factor. The argument is 3 goals can be set equal to 10 minutes and divide both sides by 10. So what I'm doing here, again, is taking 3 goals equals 10 minutes divide both sides by 10 minutes. The right side becomes 1, so this is considered a 1. Now, the next fraction must contain minutes in the top, so what? So I can do what? Well, I know, but so I can cancel the minutes and have goals left. And then, of course, I have what? 30 minutes over 1. Then the 10 and the 30 cancel, giving me 3, and 3 times 3 is 9. Now, you could do that in your head, but doing dimensional analysis gives you a way of attacking problems that you can't do in your head. Now, I'm going to again, so I'm just going to walk off camera. Let's leave that where it is, and then I'll be going back to center here in a moment. Okay, give you an idea of where I'm going. Okay. Same spirit that problem was done in. I'm giving you some new problems today. Now this one I'm going to ask you to do in your head first as we put this on the screen. Here's my problem, and let me come off there just for a moment, and let's get rid of the next one because I don't want you to see that one. Okay, let's go for it. 4 pounds of apples sell for $1.50, $1.50. Now, how much are you going to pay, and I want this in terms of dollars, for 12 pounds? Don't say it, but write down what you think your answer is, doing it in your head as a proportion problem. So 4 pounds for $1.50. I want to know what you pay for 12 pounds. I want you to write a number on paper. I'm going to leave that on the screen. I want to see the number you're writing on paper, just to get an idea, just in your head if you can. Okay, I'm looking for numbers in your head to see as a proportional thought, just thinking. Are you getting the number I want as proportional thought? Let's see what we have written. Okay. Anybody else? Not yet. Do we just have a number for me at the end? Okay, again, this is in terms of what we call proportional thinking. You don't have to use dimensional analysis to do that. Okay, so I have, it looks like 2 or 3 correct answers so far. Okay. So far, I only have 2 or 3 correct answers. So I'm looking for a number. Okay, I have about 4 of you with a correct answer, and that correct answer is $4.50. Now set it up as dimensional analysis. So set it up as dimensional analysis. Let's go back to the problem. 4 pounds for $1.50. How much for 12 pounds as dimensional analysis? First fraction, this will take 2 fractions again, just like the last problem. 2 fractions, just like the last problem. So we'll leave that on the screen just a bit longer. So I have 2 fractions. And I want at the end dollars. Now this is not a bad way of setting it up as we go to the board, where I have 2 fractions and I want dollars at the end. So what does that tell me in the first fraction? Dollars on top. So if I look at this, I have to have dollars here. Now I know something about dollars from the original statement. You can buy what? 4 pounds equals $1.50. So I'm going to write $1.50 4 pounds. I'm using LBS for pounds. And then I wanted to buy how many pounds? 12 pounds. But note, since pounds are in this denominator, pounds must be in this new fraction on top, the numerator. And I have, in my problem, 12 pounds over 1. You're done. Now I check to make sure that the only thing left is dollars. It is. And of course, I could rewrite the numbers. I'm encouraging you to do this to make sure that you don't get too much garbage in the problem. This simplifies it a little bit. The units are already gone. And so I have the cancellation here, and 3 times 1.5 is 4.5. So $4.50, but we say $4.50. Now that's, again, much like the problem about soccer. Same idea. Now this set of problems I'm going through today get progressively more difficult. They start out easy like this, and they get to the point where it's harder and harder to do them in your head. So as I come back to the problems, I'm going to look here in a moment. This is the kind of thing that you talk about on a test. Okay, I have a test coming up in one of my classes. And let's say that they can do 8 problems in 15 minutes. So that means about 5 minutes a problem, right? A little more than 5 minutes a problem. And they're going to take a test. And I want to know how long it will take them to do 30 problems. Now the argument here, do they have enough time to do the test in 1 hour, if that's how slowly they are doing the problems? And I think you can just look at that and say, in 1 hour, you aren't going to get 30 problems done. So it's going to take more than an hour. Can you get me an approximate answer looking at the numbers, trying to do it in your head without? I want to know how many hours is the phrase. So how many hours? So let me slide that over just a bit. How many hours to do 30 problems if you can do 8 problems in 45 minutes? An answer in your head first. This again is what we call proportional thinking. And just if it gives you any comfort, when you feel stressed, you're inclined not to try to do it. You make an option and say, no. Okay, 3 hours for one person's solution. Anybody else have an estimate? Anybody else think they have an estimate for how many hours? 5 hours. I have a 3-hour number. Anybody else? 4 hours. Anybody else? So I have a 3, 4, and 5. 4.5. Anybody else? Anybody else have an estimate?
4 hours and 45 minutes.
Between 4 and 5. Okay. Let's see what we're going to do. Again, my template for a problem like this is to go ahead and take maybe 2 fractions together. Is that going to do it? Let's see what we have. What do we want at the end? How many hours, correct? Maybe this is going to be a 3-fraction problem. Let's come back to the board now and see what we have here. I want hours, correct? So what will go in the first numerator? Hours. Now question, do I have anything in the problem I can use about hours? Well, as we look at it, let's go back. I have minutes, but nothing about hours. So maybe I'll come back to here and say 1 hour is 60 minutes. The title of a TV show, 60 minutes. Now what does that tell me about the second fraction? What must be there? Minutes in the numerator. So this has to be minutes here. Now is there something in the problem I can use with minutes? Let's go back to the problem. 8 problems is going to be in 45 minutes. So doing those 8 problems will take 45 minutes. So back to here. 45 minutes over what? 8 hours. Didn't say that right. 8 problems. I was thinking of hours that I wanted at the end, and I should have said what? The 8 problems. That was a bad DAE. Now, I need what in this next fraction? Problems, so that I can cancel what I had before. So that's why this is going to be problems here. Note, I can get rid of minutes. Now I can get rid of problems, but let's come back to what I had on the document cam. We had 30 problems, correct? So I put the 30 in there, Now as I look at what I can do, I can cross out problems, and I'm left with the following numbers. So let me slide the erasers over. Let me put the numbers. A 1, a 45, a 30, a 60, and an 8. And this must be what at the end? Hours. That's what I'm after. What can I do to simplify? 30 and 60, I'll go with that. That gives me a 2 down here, correct? A 1 up there. Now what?
45 and 80. Oh no, 8. Oh no. Come on, my bad. Sorry.
Anything else I can do?
No.
We have 1 hour and 60 minutes, 45 minutes for 8 problems, and I have 30 problems. So I have, it appears, what? 45 over 16? Do we agree?
Sure.
So 45 over 16. So let's just take this space here. 16 into 45. So I get a 2. Then that's 32. And I'm going to have 13 left. So that's 130. And if we look at 16 into 130, it goes about 8 times. So 2.8. So roughly, this is going to be 2.8 hours for my answers. We slide over. Now the question, no, let me still pick up here. So I want this just so we have the, there we go.
3 hours and 20 minutes.
Well, it's 2.8 hours, so that means less than 3 hours. Now, 0.8 of 60 is about 48 minutes, so it's about 2 hours, 45 minutes, 2 3/4 hours. What is wrong then with the person's study habits?
They're very slow.
He didn't mince words on that. Okay, the comment was very slow. If you're doing 8 problems in 45 minutes and you have to do 30 problems on a test, you're in deep trouble. Because you need 2.8 hours to finish that, and you're given 1 hour. So you're going to have to do what? Get this more down to 15 minutes for 8 problems, about 2 minutes per problem, and then you have a chance of doing that. 2 minutes per problem for 30 problems, 60 minutes.
Study harder.
Well, you have to get more speed in what you're doing. And that's what you face on Thursday. Because if you can do these dimensional analysis problems in 15 minutes a problem, and I give you 8 of them, you need 2 hours. And I'm giving you 1 hour. So you have to be able to do maybe 7 minutes per problem for 8 problems is 56 minutes. I hope that gives you some incentive to practice these problems. Okay, I'm going to come back to the center again, and we're going to look at yet a new problem. Now this is one, I don't know if you've ever tried going from one spot to another spot nonstop. So if you're going to go from here to, say, LA nonstop, not a problem, right? 7, 8 hours. I do the speed limit, not like some people I know, and then stop for, bathroom breaks and getting something to eat, not like Adrian, who would do 80 on I-5 and do it in half that time. 4 hours? Yeah, 4 hours if you don't get stopped. Yes. Impound your car, and then it takes you 4 days. Have you ever tried going from here to New York nonstop? 3,000 miles. Well, you would do it with somebody else with you, right? You'd trade off. So each of you drives until you can't stay awake. You trade off, the other person sleeps, and you try to get from here to New York as quickly as possible. So here's the problem. You're going to the East Coast. Now you're doing 60 miles per hour. Even Adrian on the roads we're going to go could not average much more than that because you have to slow down going through the towns and a few other places. But it's 3,000 miles, and the drivers, we'll make that plural, do not stop other than to change off, get gasoline, and that's why your average is slower. Because you can't do this in one tank of gas, even with the Prius. Now, How are we've had estimates before. How long do you think this is going to take? Let's estimate. Do I hear some numbers? No, just a rough estimate in your head. What do you think?
2 days.
2 days?
I'll say 3.5 days.
3.5 days? 5 days? 7 days? So we're going to do it within a week. That's the argument. So as we come off there, let's see what we can remember. You're going 3,000 miles, right? You're doing 60 miles per hour. How many days to go the 3,000 miles? Set up the first, non-stop, first fraction. Write me the first fraction, and I want to know how many days.
Can I see it?
Just give me the first fraction written down. Just want the first fraction written. Remember, at 60 miles per hour you're driving. You're going 3,000 miles. I want to know how many days to get from here to the East Coast, which, just for the sake of argument, we'll say New York City, Manhattan Island. 60 miles per hour, and you are going to go 3,000 miles non-stop. Okay, in the space behind me, Marcella, we're going to go to the board. And are you ready for that? Just nod, okay. We're going to go over here now. And again, I'm going to do what? Start with some fractions. We don't know how many we're going to need, but I wanted to know what? Days. So what must have gone in your first fraction? Days in the top. Now, if I do 1 day, and I'm talking about hours, how fast you're driving in terms of hours, it makes sense to do this. Keep in mind, this only works because we're doing non-stop driving. If you decide to do 8-hour days or 16-hour days, you would adjust it. But we're arguing here that you're going to just drive non-stop. This is like an 18-wheeler, has to deliver cargo. The 18-wheeler has a problem because they have a log they have to keep, and they won't be allowed to drive 24 hours non-stop. Okay? What must go in the next fraction? Hours. Now back to the problem. I'm going to use HR for hours, not human resources, but hours. And the question, do I have something from the problem that allows me to use hours?
60 miles.
The 60 miles per hour is what? So we come off there. When you say per hour, it means what? 1 hour. So it's 60 miles in 1 hour. So I can put my 1 hour up here and my 60 miles here. Now the hours cancel. I want days. So what must go in the next numerator? Miles. And I have 3,000 of those over 1. Now I'm going to do the numbers. Only, no dimensions. My miles have canceled, my hours have canceled, and I'm left with days. So that gives me a 1 times a 1 times a 3,000 over a 24 times 60 times 1, and this must be days. Are we ready? How many times will 60 go into 3,000? I want 60 into 3,000. Okay, this is going once here and goes into here what? 50, correct? Now I have 50 over 24. Can I reduce it? Yes. But I'm not. Because there's 24 hours in a day, right? So maybe it'd be nice just to do this and get 2. With 2 left over. That's 2 and 2 24ths of a day, which means 2 days and 2 hours. Or 2 and 1/12, which is 2.08. So the answer here is going to be 2.08. And then there's some 3s, I think, that follow. So just a little more than 2 days. So
I
Teresa was right at 2 days. Okay, now if you haven't eaten in 2 days, you haven't showered in 2 days, you're grumbly, you need to sleep because you haven't been sleeping very well because of traffic, you probably aren't in much of a shape to do anything, but you're there.
You've been a good spot to be grumpy down in
Yes. Oh, that wasn't fair. A good spot to be grumpy, New York. Now, they would not appreciate that. Okay, New York has a reputation for being not grumpy. Okay.
Forward. Rude.
Oh, I'm letting this go. New Yorkers will not forgive us if they're watching. Okay, we're going to go back to the center again, and we'll try another problem as we come off that. Okay, this is a pretty good typist. Let's see if I can center this a little bit better. Now, I'll tell you, this is a good typist. This is the information. So what you can't read is a good typist can type 80 words per minute. So I don't even do half that well when I'm typing these days, but a good one at 80. Now the question is how many hours? 20-page paper, 300 words on each page on the average. So I'd like you to set this up, again with fractions. And how are we going to set this one up? So again, a good typist, could be a bad typist, just somebody's typing. And we get 80 words per minute. I want to know how many hours it takes for a 20-page paper. Each page, on the average, 300 words. So as we, again, set this one up, I'll just start. We aren't leaving the camera back on the problem just a bit longer, please. And then we're going to come back, and in a moment, I'm going to go to the board, and let's see if we can do this. But you should be able now, minimally, today, give me the numerator of the first fraction. You have to be able to do that at this point. The numerator of the first fraction in this that I'm going to write on the board. I wanted to know how many what? Hours. So the first fraction now as we go to the board is hours. Now I don't know what the denominator is yet, but I know hours are on the top. Let's go back to the document cam. I see that I'm typing at a rate of so many words per what? Minute. So if I go back to the board and I have hours, is there an equivalence I could use? 1 hour is 60 minutes. So that forced the first denominator. Now once that first denominator is forced, what gives the freebie that you get? What must go in the numerator of the next fraction?
Minute.
I have to be able to cross them, cancel them. So if I have minutes here in the denominator, I have to have minutes in this numerator so that when I'm done, I can cancel those units and be left with hours. That's the idea. Back to the document cam, please. Now, do I have any information here that allows me to put minutes in the top with any of the information there? Anybody? The 1 minute and 80 words. So back to here. 1 minute, 80 words. What must go in the next numerator? If I have words here, the only way it's going to cancel is if I have words up here. So we'll put words here. I know the words will cancel now. Back to the document cam. And what do I have?
300 words.
300 words per page. So 300, 1 page. Well, the words are out, but what has to go in the next?
Page.
PG for page. And how many pages do I have?
20 over 1.
20 pages over 1. The page cancels. Now I need to write the numbers. This is cleanup time. So I have a 1 times a 1 times a 300 times a 20. It is over 60 times 80 times 1 times 1. And what do I have to make sure I write? Hours for my units. Now, can I simplify anything? I tried to write this one so that life is good. The 20 and the 40, or 20 and 60, which does it make sense?
The 80.
20 and 80.
I have more people saying 20 and 80. It'll work either way. Get a 4 there, correct? The 60 into the 300, and it'll go 5 times. Well, that's pretty nice, isn't it? I have 5 left in the top, 4 on the bottom. So that would be 5 over 4, which we would rewrite as what? 1 1/4, or we could rewrite it as 1.25, and that's hours. Any one of those would be appropriate. You do have to have the units with your answer. Got the idea? Okay, let's go back to the document cam. This one was 80 words per minute and the amount of time to type a 20-page paper. Now, just a comment, we have in this problem said about 1.25 hours. But what are you likely to do in that time that you're typing this paper?
Eat, take a break.
Take a break, get a cup of coffee, walk around, answer the phone, the doorbell, yell at your kids, and 3 hours later you're still trying to get it done because you've been interrupted and didn't have time on task. At least that's the way it works around our house. So I have a rule that I use called the rule of pi. Pi is about 3. If I think something can be done in an hour, multiply by 3 and it's more realistic. If I think something can be done in 2 hours, I multiply by 3 and get 6. Works pretty well. Fudge factor. While you're eating the fudge. That's another interruption, right. Okay, let's see what we have here. I'm trying to see. This is a problem we've talked about a little bit earlier, but let's see. This is just one off of another sheet of paper. Matt was a person who was wanting to have me finance money to the school. The parents decide to donate 1 little penny, 1 cent, for every yard, that's 3 feet, every yard he jogs. Now, what does he do? This is now for 1 week. Matt, who never leaves the house, never gets away from the computer, playing the games, locked into technology, suddenly decides to do what? Jog 5 miles every day to school for 1 week. How much money, how many dollars will his parents donate to the high school athletic program before they get an evict notice to Matt, costing too much? Okay, so that's the question. 1 cent for every yard. That's 3 feet. And he's going to jog 5 miles every day to school. And does this for what? 1 week? So how much money for the week will the athletic program benefit? So I'm going to, while that's still on the board, or on the screen, I'm going to set up some fractions. I don't know how many I'm going to need, but I have a hunch I'm not going to get by with just 2 or 3. I want to know how many dollars. So what goes in the first fraction? Okay, that's a little bit better. So as we look at that first fraction, we're going to have $1. And remember, 1 little penny for every yard. Okay, so 1 penny. So we want $100 or $1 over 100 cents. I started to say $100. That would have been not a very good number. So $1 over 100 cents. Let's go back to the problem. Now what do I know? That the parents are donating what? 1 cent per yard. Back to the problem. So that means I have the 1 cent up here. It's over what? 1 yard. Now that's pretty good. The cents go out. What has to go in the next? Yards have to go up here. Oh, wait a minute. I have something about yards. Let's be careful. What am I going to? Let's go back to the problem. Is there anything with yards? Well, I get 1 cent for every yard, and you're doing what? 5 miles. So if I could get something between yards and a mile. Okay, if you go to page 66, you should find that there are 1,760 yards in what? 1 mile. So the yards are gone. We cleaned up the yard. Now what? Back to the problem. Okay, we have 5 miles each day, right? Miles are out. How many days are you doing this?
7.
7 days. I think I'll be content with the 7 days because I just ran out of room. Okay, number time. A 1, a 1, a 1, 760, a 5, a 7. In the denominator, 100. And this is dollars. Now the question, does it pay to try to cancel here? You could. I mean, in the sense that you can make it a little bit easier. You could divide 10 into here and 10 into here and have a 10 in the denominator. Or you can multiply everything in the top and move the decimal 2 places to the left. Remember, when you divide by a power of 10? So what do you have? Answer time. What?
$61.
Which is it? I've heard $616 and $61. I like Teresa's $61. Adrian's going to bankrupt me, but maybe Adrian's right. Well, let's see what we can do with this. If I divide 100 into here, I get 17.6 times 35. Okay, so let's look at it that way. 10 times 35 would be $350. So it seems to me that Adrian's about on target. What was your number again, Adrian? $1,616 then? Just zero? Just $616. The athletic department will put a plaque on the wall for you. The response, somebody needs to get Matt a bike. Okay, but this is one of those innocent problems, just a penny a yard, and you write out a check for $616. However, there's a good side to this with the new year coming up. In April, it's tax deductible. And $616 will be a tax deduction. I mean, they don't come very often like that, so you think this is a good thing. You don't eat for the next week, but you got a tax deduction. Okay, back to the document cam. Well, that was sort of a nice problem. Now, that took a lot longer than one of our first problems, correct? So let's think of test strategy. In test strategies, as we can come back, in a test strategy, you don't want to do the hard problems right out of the gate. Get the easy ones done. So if I give you 8 problems, remember the 8 problems in 45-minute kind of thing? If I give you 8 problems, the easy ones you want to get done soon. So that a problem like this that involved 1, 2, 3, 4, 5 fractions goes quickly, but a new problem. Just barely time to set this one. I want to make sure we have time for a little bit of a quiz. Let's see what we can do here. Here's one to see if you can do it in your head. It's a little bit harder because it involves a fraction. I'll say that much. This is courtesy of one of my colleagues who's from China. An expensive tea is $100 per pound. So let me slide that over. So you're going to buy a tea and you're going to plunk out $100 for 1 pound. Now you have some friends who want to share the cost of this, and you're going to put 4 ounces in packages for each of them. So the question, since they're sharing the cost, how much should they pay for their 4 ounces? Write the number on paper. We'll give you a minute or so to do this. $100 per pound, and you're going to be giving a packet of 4 ounces to a few people, and they're going to pay for it. How much should you charge them is the question. How many dollars? Write it on paper. Don't say it out loud yet. And what it helps to know what equivalence. What does it help to know?
Your ounces per pound.
Ounces and pounds, right? Okay, let's come off that for the moment. Now here's something I encourage you on a problem like this. Be able to say it without reading the problem. The tea sells for $100 a pound. You're going to sell 4 ounces to a friend who wants to try the tea. You're generous, but not that generous. 4 ounces is 1/4 of a pound because there's 16 ounces in a pound, so 1/4 of 100. You should have had $25. And that's a problem that you can do in your head. Now write it in dimensional analysis form. So let's bring the problem back up one more time, and we're going to see if in a minute's time you can write me the solution as a dimensional analysis. 2 fractions. So we're going to have 2 fractions again. See if that'll do it. Back to the problem just for a moment longer in case people are still trying to figure out what to do as they watch it at home this afternoon. An expensive tea. And by the way, there are more expensive teas than this. This just happens to be a $100 per pound tea. Now, I want to know, okay, how many dollars for 4 ounces? Okay, by the way, the response just given to me was drink soda, but I hope you realize that there's a study out this morning, reported I think in the paper, that says this is really a downside for women because they're drinking a lot more soda, and what's happening to them? They're getting calcium deficiency, and they are getting broken bones as a process because they aren't getting calcium. They are drinking sodas instead. So, and you drink diet soda, so you don't have to worry about the calories. Now, I want dollars, right? So what is my answer going to involve? $1. Is that it? Or is it more than $1? Let's look at the problem. Ah, it's $100 and what? Let's leave that up for a moment. $100, and per pound means what? 1 pound. So we put $100 over 1 LB. Now what? LB has to be here. So cancel them. Back to the problem. It has ounces, correct? So that leads me to an equivalence that 1 pound over 16 OZs for ounces. And that means pounds canceled. One more fraction. I couldn't do it with 2. So the third one. And I'm going to have, and that certainly didn't come out looking very level, 4 ounces is what I was going to provide. The ounces cancel. Okay, this then gives me 100 times 1 times 4 over 1 times 16. This is in dollars. And so that's where we canceled here, and the 4 into 100 went 25. And so we had indeed $25. Okay, we need to do a little bit of a quiz in here in the last few minutes, so we're going to cut this just a little bit short today so we can get that done.